All right, so let's get started. Okay. So today I'll be just going over the homework 6. And how many of you already started homework 6? Okay, a lot of you have already started. So essentially homework 6 has to do with while loops and for loops. So let's go over that. One second. Okay. All right. So in the first question, essentially you're asked to use a nested for loop, right? So before week 6, all you had to do for the nested for loops, or rather, so in the part A, the problem 1A, you just need to use one for loop because the variable n here is varying from 1 to 100. So the idea here is this simple, right? So before week 5, we didn't have loops in the picture. So all you had to do was to, so all you had to do was to use just 2 lines of code and use a summation function and get the work done. So you can get the answer to this question without using a loop, essentially. So here n is going from 1 to 100, and let's say S1 is the sum of all the numbers in the series that vary from n equals 1 going to n equals 100. Okay? So if I go ahead and run this, I see that S, so one of the ways you can check this is directly you can see the value of S1 in the workspace. It's pretty close to like 0.99, so it's pretty close to 1. So you can do the same thing with a for loop. So all you have to do is use a temporary variable S2, right? In this case, I'm setting it initially to 0. And then I'm using a for loop to get the value of S2 iteratively, and I'm updating the value of S2 as n is varying from 1 to 100. So here, so this will give you the same answer as S1, because essentially what I'm doing is instead of applying a summation operation on the series, so here I'm creating the series and like summing all the terms, here I'm updating the value of S2. So let me go ahead and run this. Yeah, so S2 here is also 0.9901. Now, how do you do this same operation in a while loop? So here, the question is asking for the sum of the values from 1 to 100. So one of the conditions that you can, so in a while loop, usually you have a condition, right? And once the condition is met, the while loop stops, and it gives the answer. So the same operation that I performed in the previous loop, I can use a while loop instead. can start from n equals 1, and I can use the condition that n is less than 100. And until n is greater than 100, this operation keeps on happening. So here, I'm using the same concept as in the previous case. I'm setting S3 to 0. S3 is holding the sum of the values. And I'm updating S3 as n is varying from 1 to 100. So I'm setting n equals 1 here. So in the previous case, in the for loop, there is no prior value of n. But here, you do have a value of n that I'm starting from, and I'm updating it each time. Just one second. I'm updating each time, and as n approaches the value of 100, it is stopping, and it is giving you the value of S3. So if I go ahead and run this section, so that is also giving me the same answer. So there are essentially 3 different ways of doing the same problem. So that's what I'm trying to show here. Yeah, you had a question? Can you hear now? That's weird. Okay. Yep. Can you hear now? You can reply in the chat.
Yes, now I can hear. Thanks.
Okay. All right. Okay. So just to repeat what I was doing, what I was telling others before. So you can perform the same operation, which is required for homework 6th, problem 1. So the essentials, essentially the summation condition. So this is a series where n is going from 1 to 100, and I can perform this operation using 3 different approaches. The first approach is you start from n equals 1 to 100, and then perform a sum operation by creating this series completely. So you have a vector of 100 cross 1, and then you sum all the values. All right? Now, the second approach is by using a for loop. So when you use a for loop, you are setting the value of S2, let's say any value, any temporary value to 0. And then you're using the for loop and varying the value of n from 1 to 100, and then updating the value of S2 as you're going. In the third case, in the while loop, you have to set n and the value of the sum, a temporary variable. The temporary variable is 0, and the value of n starts at 1. And while n is less than 100, the loop keeps operating on the values of S3 and then incrementing as this right-hand side of the series is changing. So that's That's the summary of what I was saying in the first 5 minutes. Now, the important question here is, as I increase the value of n, right, let's say here, before this, n was like varying from 1 to 100. Now, if n is, let's say, the maximum value of n, let's say let's call that variable num, that is, let's say, 10 to the power 5 in this case. Okay? So now the important question is, there are 3 different ways to do the same thing, and which is faster. So if I go ahead and execute this, so instead of just having 100 values, let's say the number of values is like 10 to the power 5 in this case. So the first approach, which is using the summation approach, is performing it in a very small, let's say this is like 0.7 millisecond, right? In the second case, the for loop, it is taking slightly longer time. And the while loop is also taking almost the same time. So here, what I wanted to emphasize here is that the for loop and while loop are not very different. They are just different ways of doing the same problem. However, if you think about it, the operation using the sum operator is highly optimized. So Matlab usually optimizes these internally, and it gives you a speed up of, in this case, I would say 0.4 milliseconds, right? So this 0.4 milliseconds may not be a lot, but then if you're thinking about these huge matrices and performing these operations iteratively, these 0.4 milliseconds can actually matter when I'm performing, let's say, 100 or 1,000 such operations on a very large scale. And this value of num here is like 10 to the power 5. And in the real world, let's say the data in the modern computers is like order of terabytes, right? So that's like order of 10 to the power 12. And there, in those scenarios, these numbers actually make a big difference. All right. So moving on to the next concept. So the problem B and C would involve nested loops, right? Because here you have, instead of just n varying, you have another iterator, which is m. And that is also varying from 0 to 100. So the idea is essentially the same. Instead of one for loop, you're going to use 2 for loops. I urge all of you to try it. So the idea is that, let me see if I can show you that. Yeah. So you would have one for loop which is present inside another, and as m and n are varying, the value of the denominator or the series here depends on m and n, right? So that varies, and it kind of increments the value of the summation operator S2. In the third part here, the value of n is varying from 0 to m. So if m is, let's say, for example, 5, the inner loop is actually varying from 0 to 5. It is not moving all the way from 0 to 100 for each m. So this is slightly different, right? And to account for that, you need to make sure that nested loop is implemented correctly. So here, yeah, if there are 2 for loops with incremental, with the dependence between those 2 increments, right? So n and m are depending on each other. M is not depending on n, but n is depending on m. So when that happens, your value of S2 will change during each value of m. So in the first, let's say, for example, if m is 1, n is going from 0 to 1. If m is 2, n is going from 0 to 2. So the inner loop has different operations, different number of operations during each value of m. Okay? So Other than that, the concept is the same. You just put two loops inside each other, and that is called nested loops. So nested for loops, you can have nested if statements as well, right? So if you have one if statement inside another, it's called a nested if statement. So yeah. Now in problem 2, right, you have let's say the square root operation performed multiple times, and it's performed in such a way that the square root operation is acting recursively on the value of the inner variable. So if you want to use a for loop in this kind of scenario, all you need to do first is to figure out the number of square root operations. Okay? So for example, in problem 2a, you have, if you count the number of square root operations, so can anyone tell me how many square root operations are there?
10.
All right, so yeah, so the number of square root operations is 10. And once you figure out that there are 10 square root operations, you can formulate a for loop to implement those 10 calculations. So how do you do that? So essentially, yeah. So let's say, for example, part B, right? Part B is slightly harder. So let's take a look at that. So in part B, you have 1 plus 2 times square. So the innermost part here, there is a square root operation that has to happen when the value of the iterand is 1. So for example, let's say here if n is 1, right? If it's part B, yeah. Let's say if n is 1. So if n is 1, you would have, okay, I think it should be 0. Yeah, I think this should be 0. Okay, so if n is 0, wait, sorry, I misspoke. Okay, n is actually 1. So in the first iteration, n equals 1. Initially, s is 0, right? So when s is 0, when the problem enters the for loop, it becomes square root of 1. And that's the innermost part of the for loop. So you can see here that the innermost part of the for loop is square root of 1. Now, as you move outside, right, as you move outside, you can observe that you need to multiply this square root operator by 2 and then add 1 to it. So that's exactly what you have done here. So you multiply the square root operator by 2 and add 1 to it. So when you perform this operation recursively, you kind of get the value of s, and this s keeps incrementing such that it is performing this operation 10 times. So that's why n is going from 1 to 10. So here, you can see here that what is the statement here does not depend on the value of n. What does that mean? It means that, like, let's say, for example, if I go from n equals 10 to 20, is the value going to change? The value is not likely going to change because you're performing the same operation 10 times. So does not matter what the value of n is. Like, as long as n travels between 10 values, right, such that this operation is executed 10 times, the value of this the final value of s will not change. So let's say if, for example, here, let's go ahead and execute. All right, so I'm getting s as 2.4136, okay? So let's say I'm going from n equals 10 to 20 and run the same section. So I'm getting a slightly different value, 2.139. Let me go ahead and Okay, so 2.4139, right? Now I'm going ahead and like performing, let's say, n is going from 1 to 10. Okay. I'm clearing the workspace and I'm running it again. Yeah, so 2.4136. Okay, in the second case, let's say I'm going from 11 to 20. I think previously I mistyped it to be 10 to 20. So yeah, so I'm getting the same value of 2.136. So it does not depend on the value of n. The operation itself does not depend on the value of n, as long as it's executed 10 times. Okay. And in the part C, right? So there is a negative sign which is alternating between the operations. So you can observe that when in the innermost value you have so you have a negative operation that alternates between amongst the value of n. So you will need to have this minus 1 to the power n, right? So that's exactly what. So let's say, for example, if n is 1, you would have minus 1 to the power 0, right? And that would be 1, and s would be 0. So at n equals 1, the value of s would be square root of 2. Okay? So if you go back here, yeah, so the innermost value is square root of 2. And once you change the value of, once you go to the next n value, let's say n is 2, right? You will have minus 1 to the power of 1. So there will be a minus sign here. So if you have the minus sign, you will have 2 plus square root of 2, because s is now square root of 2. Sorry, 2 minus square root of 2, because there's a minus 1 to the power of 1. So 2 minus square root of 2. And then that operation keeps alternating. Okay? Now, any questions on problems 1 and 2? Because that's important for the rest of the problems. All right, so let's go to problem 3. Okay. So one of the most important topics in this Matlab class is when to use a for loop and when to use a while loop. So when you have a condition specifically that is required to be met, you need to use a while loop. And when you don't have a condition, so usually you can formulate a condition using an if statement, right? You associate a condition to an if statement. So if certain condition is satisfied, you execute this, right? That's the general mode of writing the code. So if you combine a for loop and an if statement, you can actually implement the statement inside a while loop. And I'll show you how. So that does not let me go ahead and pull up problem 3. Okay. So one of the ways of solving the third problem is by directly using a condition here where you have a while loop. So while the condition is not met, the n keeps incrementing. So this is very important here. So the question is asking, what is the smallest value of n that satisfies this condition? Which means, let's say n is 0, right? So the value of e is definitely greater than 10 to the minus 9, right? So as you increase the value of n, the denominator keeps increasing. And at some point, you're going to have this left-hand side being less than 10 to the power minus 9. So you need to start with a value of n, which is really small, in this case 1, and then you need to keep increasing the value of n until you reach a point where the value of n is such that e divided by n plus 1 factorial is less than 10 to the minus 9. So this is where a lot of confusion happens. So we need to execute this statement until this condition is not met. So what do I mean by this condition not met? I mean that if or while e divided by factorial of n plus 1 is greater than 10 to the power minus 9, right? So here there's a greater than sign. Why do I put a greater than sign? Is because I need to change the value of n until this is not true. So that will give me the smallest value of n, if that makes sense. So here I start off with n equals 1, and the first time it goes inside, it checks this value, and the value of the left-hand side is e, right? Or e divided by 2 factorial for n equals 1. So e divided by 2 factorial is, so e is like 2.7, right? So e divided by 2 factorial is close to 1. So 1 is definitely greater than 10 to the power minus 9. So it goes inside and then increments the value of n to 2. So once n is 2, it goes back, and the next time it checks, so it will be e divided by 2 plus 1 factorial. That is e divided by 3 factorial, which is e divided by 6, right? So that is slightly smaller than 1. And that is still greater than 10 to the power minus 9. And this operation keeps on happening until at some value of n that this statement is no longer valid. An easier way, or a different way to implement this is by using an if statement and a for loop. So if I want to get the same operation or implementation done using an if statement and a for loop, now I don't know what the value of n is at which this condition is getting satisfied, right? So I start off with a for loop and a value of n which I don't know the upper limit to. So I need to assume a large value of n. So in this case, I'm going to assume like a really large value of n, and then hope that between 1 and, here it's 10 to the power 7, between 1 and 10 to the power 7, the value of, at some point, it's going to satisfy this condition. So the condition is that, let's say, for example, as you increment the value of n within a for loop, if at some point e divided by n plus 1 factorial is less than 10 to the power minus 9, it is going to break. So how many of you know what break is? Okay, so not everyone. All right. So break statement is essentially a way to get out of the loop. Okay? So whenever there's a break statement, and when the break statement is called, this loop stops. And the break statement forces the operator to move away from this loop. For example, in this case, let me show you. So I'm going to go ahead and run the first section to just see what is the value of n. So I got the value of n as 12, right? Now, in the second case, I'm going to display the value of n each time. I'm going to run this section. Okay. So you can see here that n starts from, I think I should increase this. Yeah. So n starts from 1, 2, 3, 4, and at some point 12, it goes inside it starts checking the if statement. At n equals 12, when it checks the if statement, it sees that, okay, e divided by n plus 1 factorial is actually less than 10 to the power minus 9. So what does the break command do? Break says, OK, now you need to leave the loop. That's what break command does. So when there's a break, when the code encounters a break command, it just stops the loop, and it comes outside, and it just stops all the operation, and n is 12. N does not go until 10 to the power 7. So this is a clever way to actually stop the value of the loop, especially if you don't know what the final, let's say, for example, if I go ahead and implement this, right, I need to run 10 to the power 7 operations. So I don't want to do that. So if I want to prematurely stop at some point, I can use a break statement. So break statement is used mostly when you want to stop the loop before all the operations are completed. If there was no break statement here, the loop would keep going, and it would reach 10 to the power 7, and I'm wasting all these operations just for absolutely no reason, right? Okay, so in such cases, ideally it's better to use the while loop because you can just check the condition and give the value. And as you've seen in the first problem, while loops and for loops take the same time in terms of computation. So you're not really saving much by switching to a for loop and an if statement. So in homework 6, problem 3, you essentially, whenever there's a condition to be checked over a value of n, you always use a while loop, because implementing a for loop is going to have an if statement and a break statement inside. Okay, so problem 4. Problem 4 is slightly harder, so I'm going to go ahead and explain that. All right. In problem 4, you start off with the ball, right? So that's 10 meters above the ground. Each time the ball bounces, it goes to 3/4 of its previous height. So this is at n equals 0. There hasn't been any bounce. So n is the number of bounces. So there is 0 bounce right now, and the height is 10 meters. Now, at n equals 1, what happens is the ball bounces, travels 10 meters, and then it goes back to 3/4 of its height, and then comes back again. So essentially, the distance traveled is actually 10 plus 2 times 3/4 of the height, right? So that's when n equals 1. So the ball would remain somewhere here. So it performs this operation and then comes back to this height, which is 10 times 3/4. So 3/4 is 0.75. So the total distance traveled at n equals 1 is 10 plus 2 times 0.75 times 10. So that is 1.5, 25. So that's 25. Okay. All right. So once you figure that out, you would know that in the next bounce, it would travel. So this is for n equals 1. For n equals 2, it would travel a distance equal to 10 plus 2 times 0.75 times 10, which is the previous distance, plus an additional distance equal to, so this is the previous height, right? So in the next iteration, let's say n equals 2, it would travel a smaller height. And the smaller height would be 10 times 3 by 4 times another 3 by 4, right? Because this is the previous height, and it travels to 3/4 of the previous height. So it would be 10 times 3 by 4 times 3 by 4. So that would be the height. So the distance would be it's n equals 2. So it's 10 times 3 by 4 times 3 by 4, which means it's 0.75 square times 10, right? Does that make sense? Okay. So each time, it's bouncing back to a smaller height. And notice that, so n is 2, and the exponent here is 2, right? So you can write that for any n, the distance traveled is actually the distance traveled is 10. This 10 is coming from the initial distance that it's covering, and this is always going to be there. And the remaining part is 0.75 0.75 power n, right? So this is the height that it's going to reach at so each time I'm summing over, so this is n equals 1, and this is n equals 2. So n is going from, let's say 0 to, I don't know, let's say capital N number of times. So here capital N is the number of bounces, and each time it bounces, it's going to travel a total distance equal to this value. So let's say, for example, we want to find the number of bounces before traveling, let's say 68 meters, right? So if the total distance is that, so if you're going to if you get the distance after n bounces, now it's easy, right? You have to just compare this to the value of the total distance given in the question. So the question says, so the question here is for 69.99 meter. Let's say, so I've performed this operation for 68 meters. So initially, when n is 1, the distance covered is, as you can see, 10 plus 2 times a quarter of 10, right? And then you keep adding this distance over and over, and you can actually get that expression. So the best way to implement this is just using a while loop. You can also try using a for loop and an if statement, but that would be slightly harder. If you perform this and repeat it for multiple bounces, So you can observe that for traveling a distance of 68 meters, it takes 12 bounces. You can change the value of the distance to check at what value of n it's actually covering 69.99 meters. Any questions on this? No? All right. So I'm going to stop at problem 5. So here in problem 5, you need to figure out the occurrences of a particular substring. So what do I mean by a substring? So for example, you have these word counters, right? If you go to, let's say, Microsoft Word or Google Docs or anything, it is going to give you the number of characters in the particular essay or whatever that you are writing. And it is also going to give you the word count. It's going to tell you how many times a word has been repeated in your text. So in this case, you have a string. So that's a string a.mat. Recall that string is essentially a collection of characters, right? So the first thing that you need to do is to load the string. Okay. All right. So you have the string here. Okay. This string is essentially a collection of characters, and in this case it's a paragraph from a book. Okay. So you'll notice that there are multiple words, and you need to find out the occurrence of a particular word. Okay. So one of the easiest ways to do that, let's say, for example, if you want to find the occurrences of the word with, let's say. Okay. So with has 4 characters, W, I, T, H, right? So what you can do is you can use a loop, and at each location, you can check each substring. So what do I mean by a substring? So this is a substring, right? So string A of n to n plus 3 is a substring. What do I mean by that? Let's say, for example, for n equals 1, string A of, for n equals 1, it would be 1 to 4, right? So that is the first word, this. And if you keep on moving, for example, n equals 2 to 5, it would be, there's a space here. So essentially what I'm trying to do is I'm trying to dissect the string A into collection of 4 characters. Okay? And each time I do that, I'm trying to compare it with the word with. Okay? So when the comparison is made and when we find a match, this counter, which is the number of occurrences of this word with, actually increases by 1. So here, for example, the number of times initially the count is 0. So count is the number of occurrences of a particular substring. In this case, the substring is with. And if I go ahead and run this, I observe that the count is 4. So in other words, there are